Hello, you're welcome to this lesson. In this video, you are going to solve this question I have here on the screen. The question says, a circular bar is loaded and supported as shown in figure 1. A. Find the reaction at the support. B. Determine the internal forces and stresses at cross sections A, B, and C of the bar if the diameter of the bar is 20 centimeters. And C. Sketch a stress diagram. So let's go ahead and then solve the question. So first of all, you will have to draw a free body diagram for the bar, and then that will give us what we have. And then you are going to indicate the reaction with letter R, and then you will choose a direction for the reaction. So for now, you will have to choose the direction for the reaction yourself because you don't really know which direction it will be in. That will be proven at the end of the calculation. So for now, I chose the upward direction for the reaction. So you are going to see that the sum of the forces should be equal to 0. This is because the reaction force is going to balance the external forces. And in this case, all the forces are in the vertical direction. So let's take note of this. So we will consider the upward forces to be positive and then the downward forces to be negative. So let's go ahead and solve for the reaction force. So we're going to have minus 10 plus 8 plus 8 minus 12 plus r to be equal to 0. And then we are going to simplify this and then solve for r, which will give us 18 kilonewton, which will be the force at the support. So from here, let's move on to the B part, which says that we should determine the internal forces and stresses at cross sections A, B, and C of the bar if the diameter of the bar is 20 centimeters. So we will look at the cross section A first. Okay, so we have a free body diagram for that part, and then we have R sub A, which is indicating the reaction at point A. Okay, so you have to calculate for R sub A. So we are going to have the sum of the forces to be equal to 0, and then that will be equal to minus 10 minus R sub A because they are all pointing downwards. That's why I have both of them to be negative. So you will solve for R sub A, then that will give us minus 10 kilonewton. So from here, we will have to determine the stress at the section A. We know that stress equals force over area, and we already know the force acting at section A, but we don't know the area. But we've been told that the bar is a circular bar, and then we've been given the diameter of the bar to be 20 centimeters. So we can use this to calculate for the area of the bar. So we have the area to be equal to pi r squared, and we're given the diameter to be 20 centimeters. So we can divide it by 2 to get the radius, and then we do the substitution to get our area, which will be 100 pi. So we can now go ahead and then calculate for the stress. So you're going to have the stress to be equal to the force over the area. So the force will be 10 kilonewton, which is same as 10,000, but don't forget it is negative. And then the area will be pi multiplying 0.1 squared. So the reason I have 0.1 there is that the the diameter was given in centimeters, so the radius will also be in centimeters, but stress is measured in Newton per meter squared, so we must change the centimeters to meters. So we used the conversion. 1 centimeter will be equal to 0.01 meter, and then that will give us the diameter to be 0.2. Therefore, we're going to have the radius to be 0.1. So we calculated for the area, and then that gives us the pi multiplying 0.1 squared. So you divide the force by the area, and then that gives us minus 0.018 megapascal. And then because it is negative, you will say it is under compression. So let's go ahead and then do same for the cross section B. So we will draw a free body diagram for the cross section B, and then we sum up all the forces and equate it to 0. So you're going to have minus 10 plus 8 minus r sub B. So you solve for r sub B, and then you're going to have 6 kilonewton. So you then go ahead and then calculate for the stress, which will be equal to force over area. So in doing this, you're going to have 6,000 multiplying pi sorry, 6,000 over pi multiplying 0.1 squared, which will be equal to 0.191 megapascal. And then because it is positive, it will be in tension. So I'm going to do the same for the cross section C. So we have the free body diagram here. Then we are going to sum out the forces and equate it to 0. So we're going to have minus 10 plus 8 minus 12 minus r sub c. We'll simplify this and then we'll solve for r sub c, and then you'll get minus 18 kilonewton. So you're going to calculate for the stress also. You're going to have minus 18,000 over pi multiplied 0.1 squared. Then that will give us minus 0.573 megapascal, and then that will also be under compression. That's for the second part of the question. And now we are going to draw the stress diagram for the question. Okay, so I have my axis here. We will consider the top side to be for compression component, and then you consider the down part to be for tension component. So in plotting this, we are going to have our first plot to be 0.6 megapascal. So what I did was that the stress at cross section C was 0.573, but I rounded it to 0.6. That's why we have 0.6 megapascal here, which is going to the compression side. Then from there we have the tension, which is 0.191, but I rounded it to 0.2. So we have the tension also. And then from here we have another compression, which was 0.318, and I'll round that to 0.3. So I'm going to have this here. So this will be the stress diagram for the question. Thank you very much for watching this video. Please make sure you like and subscribe.